there a client component? Because the only reason I can imagine WebAssembly is being pulled into the setup is because they want to bundle the Rust code to be able to be available to node runtimes or something like that. Okay, that's good. Yeah. Are you seeing what I just saw? It's possible this issue has been fixed in version 0.11. Can you hear me? Months ago, that was a long time ago. 2020.
Okay, so we'll be starting the class in about 3 minutes. We're just doing the final things we need to get to start the class. I did Una 2 as well.
No, I thought perfect.
You're not supposed to share it.
No, it's for free. It's 500.
Why do you want to share it? I just want you to be just in case, just looking it up and seeing if. What's your name again, Brenda? Just be my monitor. Shibak, you dey use router. Now your phone internet they use. Your own they disconnect. It's low, ba? Okay. Because I was just thinking, I did live already. I don't know. Wow. You don't use that. Okay, so good afternoon, everybody. I'm so sorry about the delay, but we are going to be starting. Thank you for waiting as much as you could. If you can't hear me, please indicate. If you can, please do. Okay. So for want of time, I presume at this point that most of you can hear what I'm saying. So we are going to move ahead. Now, in this class, we are going to be discussing three major things. First of all, we're going to be talking about chemical equilibrium and how to handle questions on chemical equilibrium. Then we would get into calculations on thermodynamics. And extending the class from that, we might talk about one or two things about pH, and that will be that. All these concepts are going to be discussed fully with questions. So, as I said, we would move ahead. Now, the little background noise you might be hearing, please, you will not hear it again. We tried working on it, but our systems are very horrible. So, just please, provided you can hear what I'm saying, just manage that, okay? Now, let's get into it. Chemical equilibrium. The term equilibrium, as I would always say, simply implies level of balance. Once you notice that there is a level of balance, you are generally describing that concept as equilibrium. However, in chemistry, we use the term equilibrium when we are describing a dynamic form of equilibrium. What do I mean? In dynamic equilibrium, there will definitely be movement, but the point about it is, after that movement occurs, if you look at it generally, the system is still the same. What do I mean by that? Take for instance, let's say you started a class with 100 people, and within the class, one person left. And by the time the class was close to ending, one more person came in. Now, if you noticed, the class started with 100 and still ended with 100, which implies that that system is still in equilibrium, even though there was a movement. So the point about chemical equilibrium is not that there will not be any form of movement. The thing about chemical equilibrium is that even though there is movement, on the long run, you would always have a constant system. Now, having mentioned that, we would get into the definition of chemical equilibrium. You can put down if you want to. Chemical equilibrium is simply a state of a system in which the rate of forward and backward reaction of a reversible process is the same. I take it again. Chemical equilibrium is simply the state of a system in which the rate of forward and backward reaction of a reversible process is the same. So once you notice that the rate of forward is equal to the rate of backward, automatically you are considering that system to be in chemical equilibrium. So far, I hope this is understood. Indicate if you don't understand. My internet connection here is relatively okay. So those in the live class online, can you give us your own answer? So we'll continue. Okay, I would reiterate what I just said earlier on. I said a system is said to be in equilibrium if the rate of forward reaction is equal to the rate of backward reaction for a reversible process. So if you look at the options, option A says all the reactants have been used off. That has nothing to do with chemical equilibrium. B said all the products have been formed. Nah, not that. There is no further change in temperature. Still not that. And you will notice that D is the answer. Why is D the answer? The rate of forward and backward reactions are equal. So basically, that's that. Is there an E? Who's that? Anya Wuchidebere. Where are you seeing your E from? Is there E on the back? Please, the answer is D, and that's that. So yes, Maureen, you are correct. Nwogu Angela, you are correct. Nazi Chichi, you are correct. Well, Anya Wuchidebere. Okay, you retracted your answer. Let's continue. Now, with that said, we would have to continue. Having said that, things to note about a system in equilibrium, as we said, is that first of all, the rate of forward must always be equal to the rate of backward. Now, a system in equilibrium cannot be altered by a catalyst. That is to say, catalysts do not necessarily affect systems in equilibrium. You can put that down. Catalysts do not affect systems in equilibrium. If at all they do, what a catalyst does is that it increases the rate of forward and backward reaction. It simply affects the rate of the reaction. So a catalyst will enable that reaction to attain equilibrium faster. However, it doesn't necessarily cause an increase in the product, or a decrease in the product, or an increase in the reactant, or a decrease in the reactant. So just have that catalysts, all they do to system in equilibrium is that they alter the rate of reaction. So they can either make it go faster or make it go slower, depending on the type of catalyst. Now, haven't mentioned this. I think we can now get into the next one. The next part of this study I would like to quickly get into is equilibrium constant. Now, the term equilibrium constant is simply a ratio of velocity constants, and it is derived from two major laws. I don't think emphasis should be laid on those laws, but I would just like to say that whenever you think about equilibrium constants, let me take this out. Equilibrium constant is simply, as I said, so as I was saying, equilibrium constant is simply the ratio of velocity constants. We will discuss velocity constants in a different study, but just have this in mind. Now, whenever they say you should find the equilibrium constant of anything, K, the equilibrium constant is simply the active mass of product all over the active mass of reactant. So when you are considering the equilibrium constant of any system, this is the first thing that needs to come to your head. So writing it probably so it will be clearer. K is equals active mass of product. Now, the question I think everybody should be asking is, what is active mass? And okay, so if you can't hear me, sorry, I'm kind of digressing before I continue. If you can't hear me, please try changing your position, because from here okay. So as I said, if you can't hear me, please change your position. I'm trying to increase the audio, but I think it's clear enough from our ends. Okay. Okay, so back to class. As I said, if you don't understand, I will re-explain. Someone said she did not get what I said. Equilibrium constant is simply represented by the formula you are seeing on the screen. I will discuss the concept, but just note that once you are asked to find equilibrium constant, what you do is active mass of product divided by active mass of reactant. K is what represents equilibrium constant. So whenever you see K is equals equilibrium constant. K is equals equilibrium constant. So whenever you see K is simply equilibrium constant. Now, I mentioned the formula and I said K is equals active mass of product over active mass of reactant. Let's explain what that actually means. Now, if I have a reaction, take for instance, I have a reaction A plus B reacting reversibly to give C, D. And I balance it and say this is M, this is N, and this is X, and this is Y. If I am looking for the active mass of A, the active mass of A is simply going to be given as concentration of A. Sorry, let me take this out. active mass of A, active mass of A is going to be equals concentration of A. Now, because this block we are seeing here simply implies concentration. Concentration of A raised to power M. Which means if I ask you to find the active mass of B, you do concentration of B raised to power N. Now, you know, these values we are putting out here are just unknown values. Imagine we had something like this. H2 plus O2 reacting to give H2O. And we happen to balance it. Put 2 here and put 2 here. And I say, what is the active mass of hydrogen? How to find the active mass of hydrogen will be, as I said, concentration of hydrogen raised to power the number of moles of hydrogen in the balanced equation. In this case is 2. So just have that in mind. Now once they say find active mass simply means the concentration of that substance raised to the power of its coefficient in the balanced equation. So for most of the questions you are going to be coming across in JAM, they don't usually extend it to give you calculations that have to do with numerical values. But just have this in mind, that when they say active mass simply means the concentration of that substance raised to the power of its coefficient. So you can put that down, the active mass is chunk of substance. Active mass is the concentration of a substance raised to the power of its coefficient. Concentration of a substance raised to the power of in a balanced equation. So anytime you think about an active mass, you are simply describing the concentration of a substance raised to the power of its coefficient in a balanced equation. Okay, now I was just looking out to see if Chuku Prizi Pet, you can't hear me. I don't actually know what's going on from your own end, but I think every other person can hear me at this point. If you can't hear me, please indicate. If you can, just say you can hear me so that I will know if it's just his problem or everybody's problem. Okay, now having said that, you will find out that when we are now asked to find the active mass of C, class, what will it become? It will simply be the conc of C raised to the power of X. Why? The concentration of C raised to power, the number of moles in C is X. If I say find the active mass of D, class, what will it become? The conc of D raised to power Y, and it's that simple. So this is this for active mass. So anytime they say find the active mass, you simply do this and you get your answer directly. I hope this is clear. If you have questions online, please indicate. If you do not understand, please indicate, and do that quickly. Okay, I'm still waiting for your questions. If there's none, I would have to continue. Okay, so for want of time, I think we'll have to move ahead. I'm not seeing any questions yet, so let's move ahead. Now, remember, the reason for describing active mass is because it is part of a particular formula, and the formula we are from constant. You are going to do active divided by active mass of reactant. Now let's see if we can do something with that reaction. We said our reaction was A plus B reacting reversibly to give you C plus D, and we said this is This is what? What do we have there initially? M.
N.
Oh, we started with N. N, M, X, and Y. So if, for instance, we are looking for the equilibrium constant for this reaction now, these guys on this side are the products, while these guys on this side are the reactants. Now, please note something. I would like you to have this in mind. The arrow is what is going to help you understand the product and the reactant. The particular direction to which the arrow is pointing is the direction of where the product is, while where the arrow starts from is where the reactant is. Why did I make mention of this? Imagine we are considering this lower arrow, which is the backward arrow or the reverse arrow. This one, let's call it number 2. Let's call this number 1. If I'm considering arrow number 2, you will notice that where the arrow is pointing to is A and B, which means the product for this backward arrow will be A plus B. I repeat or reiterate, whenever you are considering a reaction, the product is simply determined by the direction of the arrow. So when I'm considering the forward reaction, the direction of the arrow is forward, which means that the products are here. In this case now, for this particular reaction going forward, the reactants are here. But if, for instance, the question is dealing with a backward reaction, it means that the product of the backward, if you are looking at the arrow, is pointing towards the back, which means the products are now these, while the reactants are these. If you have questions, you can actually make your comments. Now, moving ahead, I'll respond to that when I see that, but let's move ahead now. Now, having said this, you will find out that if I say active mass of products, in this case, once they do not indicate backward, it means forward. I repeat myself. If they say what is the active mass of a reactant and they do not say backward or forward, what it simply means is that it's for the forward reaction. If they want it to be for backward, they will simply indicate find the equilibrium constant for the backward. But once it is not indicated, what they imply is what? Forward. I hope this is clear. Good. Now, what is the active mass of this equilibrium constant of this reaction? The active mass of the product in our forward reaction, these are our products C and D. So which means our active mass of the product, active mass of C is concentration of C raised to power X. D is concentration of D raised to power Y. Now please, you are multiplying the two of them. That's why you have a dot product here. This dot simply means multiplication. Now we are done with everything in the product side, so we go to the reactant side, divided by the active mass of reactant. The reactants are A and B, so we are not dealing with just the reactants, but their active mass. The active mass is going to be concentration of A raised to power N times concentration of B raised to power M, and that's the equilibrium constant of this reaction. I hope this is understood. Now, with this said, I just want to make some major points about finding equilibrium constants. So take note of these things. The first thing you're noting, just write notes, NB, notes to take about equilibrium constants. Number 1 is that the active mass of a solid and a liquid is equivalent to 0. The active mass of a solid and a liquid, sorry, not 0, is equivalent to 1. Sorry about that. The active mass of a solid and a liquid is equivalent to 1. The active mass of a solid and a liquid is equivalent to 1. So what does that mean? If you notice a reaction and in the reaction you have a solid, it means that the active mass of that solid will be 1. We'll get to discuss this. Now, the second thing you need to note is that the only species involved in determining equilibrium constant, the only species involved in determining equilibrium constants are the only species involved in determining equilibrium constants are gases and aqueous or dissolved ions. The only species involved in determining equilibrium constants are gases and aqueous or dissolved ions. Okay, so I presume that at this point I'm trying to be slow as possible so that everybody can follow. Now, with that said, let's just try out a question. Let's look out the question. Let me put the question up to the screen so everybody can see. Sorry, I'm trying to get trying to get the question set. Okay, so I think at this point you can see the question. So let's look at the question and then try to answer it. So let's give me your answers to this question before I explain them. Yes, those in the live class, those online, put out your answers. What do you think is the answer to this question? Okay, someone said A. Based on what we just said, what do you think? I think I should rewrite.
I can't actually see that plus or minus.
That's plus now.
Oh, it's D then.
Let me try rewriting the equation of the reaction so that you guys can easily see it. The reaction is N2 gas plus O2 gas reacting reversibly to give 2NO gas. Yes, it disappeared from my screen. Sorry about that. So I said reaction is N2 gas plus O2 gas reacting reversibly to give 2NO gas. Okay, so what do we have? That's the reaction. Okay. So what's our answer?
D.
The answer is still D. Okay. So D is. You think it's D? Okay, Maureen Onyekachi said A. Okay. I think we should answer the question. Now, the general concept or general formula for equilibrium constant is equilibrium constant is equals product, active mass of product all over active mass of reactant. Active mass of product all over active mass of reactant. Active mass of product all over active mass of reactant. Now, if you look at that question, if you look up to the screen, you will notice something, that the reactant is nitrogen plus oxygen, while the product, as you can see, is 2NO. So we are going to take the product, divide it by the reactant, and we get our answer. So that is simply going to be K for this reaction is equals the product. Active mass means concentration of that particular, the product is NO, right? Concentration of NO raised to the power of its coefficient. The coefficient is 2 divided by the active mass of the reactants. The reactants we have are nitrogen, N2 raised to power. The coefficient in the equation is 1 multiplied by the concentration of the other reactant, which is oxygen, raised to power 1. So you find out that this is your answer, and amongst all of them, the one that is most accurate is D. So I hope this is making sense. So have that in mind. Now, did you notice something? Because all of them are gases, I do not need to change any one of them to 1. This is a gas, this is a gas, this is a gas, which means it is supposed to participate in this particular process. I forgot to put the units, but just have that the state of matter. But have that in mind. Because they are gases, I don't need to change anything to 1. Provided they are gases, they are supposed to participate. So the equilibrium constant of a particular reaction is the product all over the reactant. Now, the other thing I would like to say is, so amongst your Mod Josh, you got it. Maduka How did you get A? Okay, now if you look at A, A seems to be confusing. Why is it confusing? Did you notice that in A they used a plus instead of a times? Notice that this is not times. In active mass you are multiplying. If you notice, I use dot product. And then secondly is the NO. The power is raising the concentration and not the substance. Remember we said concentration of the substance raised to the power of its coefficient, not the substance raised to power its coefficient all inside concentration. No, it doesn't make sense. So just A is entirely wrong. For those of you that chose B, why in the name of God will you choose B? Okay, I see why. You did concentration of 2NO because in the question they said 2NO. So please, that's an error. The substance is what you are looking at, and the substance is nitrogen 2 oxide. So you are considering concentration of nitrogen 2 oxide raised to power its coefficient, which is 2. That is why B is wrong. Then if you look at the other one, yeah, obviously C is so wrong. The answer is D. So have that in mind. So for those of you that are Igwe Adobe, I've corrected this, so please look at it again. Now, having said that, we will try out something else or a different question where we have a solid involved. Imagine, for instance, you are asked to find, I'll just put down this reaction basically. I wasn't able to get the question, but look, let's consider this reaction. Imagine you had, oh, where's my, yes. Sorry, my mouse is choking with me. What are they laugh? I don't. Okay, sorry, my mouth been the joke. Okay, so let's look at this. Now imagine you have this reaction. Fe solid plus H2O gas reacting. Please, reaction should. I'm just trying to. Okay, let me try to compress everything to get into the screen. You get? Yeah, and that's true. Okay, so let's look at this. Imagine, for instance, you have this reaction Fe solid plus H2O gas reacting reversibly to give Fe3O4 solid plus 4 hydrogen gas. This is also 4, and then this is 3. Now this is a balanced equation. If we are asked to find the equilibrium constant of the reaction, we are going to simply do product over reactant, right? Good. So let's do that together. Everybody write it in your own note and see what you're going to get. So you're going to get equilibrium constant is equals active mass of the reactant, which means active mass of the product, which means concentration of Fe3O4. Please indicate solid, all raised to power. The coefficient we are seeing here is 1. Let me cut this out. This is going to be multiplying. That's multiplying the concentration of hydrogen raised to power 4. Note, hydrogen is gas. Sorry about that. Trying to rearrange this. So we have that. This will be conc of H2 gas 4 divided by that of the reactants, and the reactants would be conc of Fe, which is a solid, raised to power 3 times conc of H2O gas raised to power 4. Now if you noticed, we said earlier on that once you notice a solid, that solid's active mass, you remove everything there and replace it with 1. Same thing happens here, that once you are dealing with a solid, Fe is a solid, you remove everything and replace it with 1. Remember, this is times. So what our final answer will be is 1 times this all over 1 times this. So if we tend to write this down or rewrite, what we are going to get is equilibrium constant K of C will now be concentration of H2 gas raised to power 4 all over concentration of H2O gas raised to power 4. So you have that. So if you have questions with respect to this, please ask. So we are expecting those online to ask their questions, just in case you are confused. Please ask your questions. Those here, clear? Una, where they here? So let's look at the question on the screen and tell me what we mean. What's going to be the answer to this question? The question says, for a reaction in equilibrium, species involved in the equilibrium constant expressions are dash. So what do we have? Gaseous and dissolved species, which is D, and that's correct. So for those online, the answer to this question is gaseous and dissolved. Why? If you are just joining the class, I have mentioned this earlier. So if you are just joining the class, do well to start afresh. You can meet us up at any time. The questions you have will be answered eventually. Okay, see. So everybody, you can write down the question. What is the equilibrium constant? What is the equilibrium constant? What is the equilibrium constant? What is the equilibrium constant for a reaction between So yes, what do we have as our answer? Okay. Concentration of ammonia raised to power 2 all over concentration of nitrogen raised to power 1 times hydrogen gas raised to power 3. Okay, let's see. So that should be correct. Those online, do we have any answer? Okay, the video keeps breaking. Actually, if for instance you notice a little break, you can actually go back and get the concept and then come back to the class, basically, for those of you that are streaming live. Anyway, besides that, let's move ahead. We are going to work on it and then get back to you. Service in this area is a little bit fluctuating. Okay, so back to what we are saying. Now, if you look at this particular question or this equation, we are asked to find the equilibrium constant for the reaction. So what do? Equilibrium constant is product over reactant, but not just product over reactant, active mass of product all over active mass of reactant. The active mass is the concentration of that substance. Now notice that I'm not going to write 2NH3. The substance is ammonia, not 2 ammonia. So what is the substance? NH3 raised to power the number of moles there, which is 2, all divided by nitrogen concentration. In the case of nitrogen, is raised to power 1. We don't need to indicate it, you get. multiplied by that of hydrogen, conc of hydrogen raised to power 3. So just have that in mind, that once you are dealing with the equilibrium constant, is product over reactants. Now, to make this question a little bit tricky, what if I had said what is the equilibrium constant for the backward reaction? So what do we think is going to happen now for the backward reaction? What will it become?
Concentration of
So the
nitrogen.
equilibrium constant will now be concentration of nitrogen. Now the reason is this, it's quite simple, that when you are considering the backward arrow, I told you that the arrow is what indicates the product. Where the arrow is pointing gives you the product, then where it is coming from gives you the reactant. So when you have a backward arrow, the product is now in this direction, which is these ones, which are these ones in this case. So which means these are going to be your product. So it's going to be concentration of N2 raised to power 1 multiplied by concentration of hydrogen raised to power 3, all divided by concentration of ammonia raised to power 2. And that's that. Now we can actually infer from this that whenever you are dealing with the equilibrium constant of a forward reaction, it is simply the inverse of that of the backward reaction. So please write that down. The equilibrium constant of a forward process is the inverse of that of a backward process. The equilibrium constant of a forward process is the inverse of that of a backward process. So I can simply say that K of C of F, let's call that forward. Oh, sorry. So this should be equilibrium constant of forward. Equi constant, please write yours in full, of forward. KCB would be equi constant of backward. So the relationship between them is simply going to be K of C for forward is equals 1 over K of C for backward. So what does this mean? If I tell you that the equilibrium constant for the forward reaction is 4, that of the backward reaction is 1 over 4. The equilibrium constant of the forward reaction is 5, that of the backward reaction is 1 over 5. The equilibrium constant for the forward reaction is 2, that of the backward will be 1 over 2. I hope this is clear. So those online, what if I now say that the equilibrium constant is 5 over 4? What would be that for the backward? If the equilibrium constant for the forward is 5 over 4, the equilibrium constant for the backward, what will it become? Okay, Anyanwu Chidiebere said she or he does not understand. Can you please specifically indicate where you don't understand? Is it like just tell me exactly what area you don't understand equilibrium constant, or you don't understand why the forward is equal to the inverse of the backward? Specifically indicate. So yes, Maureen, Mod Josh, I don't know what that is correct. Anyanwu Chidiebere is not 5. Okay, let me re-explain. So as I said, that if you have a particular value for the forward, to get the backward equilibrium constant, or you have a backward and you want to get the forward, just do the inverse. Once you are inverting the two of them, it's going to give you your answers. What do I mean? If I say K of C of F is 2, it means that the equilibrium constant for the backward will now be 1 over 2. Finish. If I say K of C of F is 3, it means that K of C of backward will now be 1 over 3. Now, we are all mathematics students. If you don't understand this math, it's going to be a little bit of an issue. I don't know how to help you that much. But imagine you had K of C of forward as 1 over 2. What we are simply doing is we are taking this up and bringing this down, which means the equilibrium constant for the backward will now be 2 over 1. If, for instance, I say in our own question, yes, the question I gave you, I said if the equilibrium constant for the forward is 5 over 4, you take this guy up and then bring the 5 down, and then you will get that of the backward. The backward will now be 4 will now be up, and then 5 will be down, basically. and that's that. So if you do this, you are practically going to get your answers. I hope this is quite simple to understand. So what's his name? Anyamuchi Debere, or her name. I don't know if you gotta go. Anyamuchi Debere indicate if it's clear. If it's not clear, and we can talk about this probably later. You get. Okay, so for want of time, based on what we just said that K of C of B is equals 1 over K of C of F. Now listen, if I say this and I ask you, which one of these is correct for the equilibrium constant of the forward and backward, and that is sum of both, that's sum of K of C of B and K of C and product of this and this is equals 1, product of the forward, the backward and the forward is greater than 1, and then sum of the backward and forward is less than 1. What do we think is the correct answer? Is it A, B, C, or D? What do we think? The question is, what is the exact relationship between the equilibrium constant of the backward and that of the forward? What do we think is the answer? So yes, based on what we just explained, and based on this expression. Okay. Sorry, I'm trying to set up something, if you guys do not mind. So the answer to the question is obviously B. Why? Let's go. It's very obvious now. Let's consider this. Take for instance, let me go back to my board. Now if you look at this thing now, when you rearrange this thing, you will simply notice that, let's rearrange this thing. Rearranging, you will notice that KCB multiplied by KCF is equals 1. Is this very obvious? Yes. It's very obvious. Just cross multiply. And once you cross multiply, you will notice that the rearrangement has shown that the product of the equilibrium constant for the backward and that of the forward is simply equals 1. So have that in mind. For those of you that are saying A, go big, it's not A. It is equals B. Okay. Go big. So Chukwuebuka Stanley, Anyamuchi Debere, that's smart. Chukwuprizi Pet, that's cool. It's correct. Chisom Favor, be correct. Edwin Grace, correct. So I think we can move ahead from this. Now, what I would expect you all to do is to go back and try out questions. As I said, we are all in the same group. So if you happen to come across a question that you don't necessarily understand, you are permitted to chat us up directly in the study group created in WhatsApp. But let's continue with that. Now, having mentioned this, we would have to get into the next part of the study, and that is the Chateliest Principle. I would like to discuss this one as fast as possible, so we'll do other things for the class. Now, when you mention the term, if a system in equilibrium if a system in equilibrium is affected by, if I'm too fast, please indicate, and I would reiterate. If a system in equilibrium is affected by change in pressure, temperature, or concentration, the equilibrium position of the system changes. The equilibrium position of the system changes in order to annul this effect. Okay, so I'm going to reiterate. Reiterating what I just said. I said it simply states that if a system in equilibrium is affected by change in temperature, pressure, or concentration, the equilibrium position of the system shifts to annul this effect. Okay, so what do we mean? The point is, once the system becomes uncomfortable, it changes its position to make itself uncomfortable. That's basically what it means. Take for instance, now you are standing, the system becomes uncomfortable. Automatically it changes its position to annul the effect. Okay, now let's look at what we mean. For instance, if you notice, the factors I mentioned are concentration, pressure, and temperature. These are the three major factors that affects the equilibrium of the system. I had said this earlier on, that catalysts do not all question. Let's see. Let me see if I can find it. Endo equi. Okay. Okay. I don't think I can find the question. Okay. Okay, so I can't necessarily find the question, but my point is this: that generally speaking, when you are considering the effects, if you are considering the effects of is affected by changes in pressure, temperature, or concentration, the equilibrium position shifts in order to annul this effect. So just have that in mind, that anytime a system is in equilibrium, something changes. Now please, this is not the emphasis, because in the JAMB exam you are going to write, nobody is going to be concentrating on that definition. All you need to know is this: that anytime there is a discomfort the system feels, it will change its position to be more comfortable. Take for instance, now everybody is sitting in a place where it's very hot inside. What do you do to get comfort? You go outside. If it is very hot outside, what do you do to get comfort? You come inside. That's basically what the Chateliest Principle is trying to say. Now, having mentioned this, as I said earlier on, there are only three factors that happen to affect the Chateliest Principle, and those things are change in concentration, temperature, and finally change in pressure. So we are going to be considering the effects of these changes on the system basically. Now let's start with the first one, change in concentration. For me to describe change in concentration, I like using this illustration. If we all know what a seesaw is, I think it will be easy to understand this thing. Now, if you consider this seesaw now, take for instance, you have this side as the reactant side and this side as the product side. Now, if you notice, it is in equilibrium. If I put one block here and I have one, I'm reactant and this is the product. Now notice, as I said, initially it used to be balanced, but now its balance has been altered. according to the Chateliest Principle, it says that when the system notices this thing, it would cause a shift that will annul it. Now, can you please tell me how it is going to annul it? It is going to simply add something here. Now, I would like you to always have this in mind, that the system cannot remove. The system can do is to add something. So when you add to the reactant side, the system will go ahead and add to the product side. And once you add to the product side, balance would be restored completely. You have here 2, you have here 2, and this will restore balance. So have that in mind, that if a system had 1 1 and you introduce one particular block to the reactant side, it changes it to this particular position. However, the system will need to restore the equilibrium by adding to the product side. Now, the conclusion of this whole illustration is this, that if the reactant concentration is increased, the system increases the concentration of the product. So that is what I want you to write. So please put that down. If the concentration of the reactant is increased, if the concentration of the reactant is increased, the system induces an increase in the concentration of the product. If the concentration of the reactant is increased, the system induces an increase in the concentration of the product. Okay, so you write this down too. On the other hand, if the concentration of the product is increased, the system increases the concentration of the reactant. So please, as much as we have heard this is the most important point you should take down amongst every of these illustrations we've made. Just have that in mind, that once you increase that of the reactant, system increases that of the product. But when you increase that of the product, system increases that of the reactant. Now, another way to say this is that if the concentration, put this down please, for those of you that are writing, put this down, because with these notes we are going to be answering the questions that we'll be considering. So if the concentration of the reactant is increased, increase reactant, the system favors forward process. The system favors the forward process. If the concentration of the reactant is increased, the system favors the forward process. So which means that if the concentration of the product is increased, the system favors the backward process. So please put that down. If the concentration of the product is increased, the system favors the backward process. So let's look at the question to help us understand this. Okay, I thought I had, okay, question cannot be uploaded to the screen, but let's just try to listen to the question as I call it out. I wasn't able to put it up. Okay, so let me try to just send it across to the group quickly. Okay, so far so good. If you have questions, please, those on the group, just indicate. If you don't understand and you want me to repeat, please indicate. Now, let's try out this question. The question says, in the reaction E plus F, in the reaction E plus F, in the reaction E plus F is a reversible process to give G plus H. The backward reaction is favored. The backward reaction is favored if dash. Let me see if I can actually send it across to the group quickly. Screenshot it and send it so we see the options. Okay, let's send that to the group. Let's see. Do that quickly. Please hold on a little bit while we put up the question so everybody can see it. Okay. Okay, sorry, I was trying to get the question to come on live. Yeah, I think we can all see it now. So, what do we think is the answer to that question based on what we just said? Sorry about the delay. Okay. So, what do we think is the answer? They said in the reaction E plus F reacting reversibly to give G plus H, a backward reaction is favored if the concentration of option A, F is increased, option B, E is increased, option D, E is reduced, option D, G is reduced. What do we think? She said G is reduced. Okay, which is D. Okay. Any other answers? Those in the live class. Online, I meant to say. Okay. So what do we think? Sorry about that. Okay, so I presume at this point you can hear me. Hmm? To answer the question, I would retake what I just said. So let's listen. If we look at the screen, if you want to favor the forward reaction according to what we wrote, if you increase this side, which is E and F, the system increases G and H. This should be clear. Which means if you increase G and H, the system increases E and F. So the concept or how to understand these questions, or one thing I want you to take note of in these questions is this: that anytime you are looking at a question and you see the term favor is not necessarily your action. It is simply the action of the system. So when they say favors backward or backward reaction is favored, it means that the system will increase the backward, which is E and F. The reactant side is the backward reaction. So if the system is increasing the backward, what will you do for the system to increase the backward? What you're going to do is to increase G and H. I hope this is clear. For those online, please indicate if you are following. They said okay. So as I said, I take it again that when you hear the term favored or favors what is what the system is going to do, and your action and that of the system is always going to be different. I take it again in this case, when I increase E and F, system favors the production of G and H, which is forward backward. The concentration of the reactant, if the concentration of the reactant is if the concentration of the reactant is reduced, the system increases the concentration of the reactant. Yes, if you reduce reactant, system increases the concentration of the reactant, hence favoring the backward process. I take it again. If the concentration of the reactant is reduced, the system increases the concentration of the reactant. We're not talking about increase now, we're talking about reduction. Just have that in mind, that in a case where it is reduction, let's consider this screen, for instance, to explain. If you look at something like this, let's look at our seesaw, for instance. You consider our seesaw. So if you have our seesaw, and let's say you had 1, 2 here, and you have 1, 2 here, this is the reactant side and this is the product side. Now, if peradventure something happens and I happen to remove 1 from the product, you will notice that this is going to fall in this direction. 2 will be here and 1 will be here. To restore equilibrium, the system will need to add back to that product side. I take it again. Imagine, for instance, we had this. Let's take this all out. Okay, so you have a particular system that is stable. It is in equilibrium. Here, okay, sorry, is the reactant side, and here is the product side. If I add 2 to this side and add 2 to this side, but once I remove 1 from this product, automatically something happens. You will notice that it will tilt in this direction. And if it tilts in this direction, how will I restore the equilibrium? You have reactant here, you have product here. If I'm going to restore equilibrium, I need to replace the product I removed. So in the situation where you are removing, once you remove something, system replaces that thing you remove. So have that in mind. Now when you remove a particular concentration or reduce the concentration of a product, system replaces it. In conclusion, what we wrote earlier on, as we saw, is if the concentration of the reactant is reduced, the system does what? Increases the concentration of that reactant. On the other hand, if the concentration of the product is reduced, the system increases the concentration of that product. So have that in mind. Please put that down. I take it again. If the concentration of the product is reduced, the system increases the concentration of that product. If the concentration of the product is reduced, the system increases the concentration of that product. Oh, come on. Okay, so I presume those online, please, if you can't hear, can you please indicate? Can you guys hear? Live streaming. You can hear? You sure? Please don't trust this boy. Okay, now at this point we would have to continue. Chukwebuka Stanley, I don't understand. I would have to reiterate some of the time, but just listen. Let's just move on with this. Now, if you look at what you wrote, you simply stated that anytime you reduce reactant, system increases that reactant. If you reduce product, system increases product. So let's look at these options again. When you say favors backward, you are considering what the system does, which means system is going to favor or increase the backward, which is the reactant. If the system is going to increase the reactant, look at the conditions. If the system is going to increase the reactant, to increase reactant, backward process. If you are going to favor the increase in reactant or favor backward process, what must be done is reduce the reactant or increase the product. Reduce the reactant or increase the product. Okay. So now you will reduce product. And secondly, we will increase reactants. So please, let's put this down, reconsider it again. Those of you that are confused, I am going to repeat what I just said. Just look at the screen. The screen says if you are going to favor backward or increase reactant, just know that what you are going to do is reduce the reactant or increase the product. That's how it works. But when you want to favor the forward or increase the product, what you simply need to do is reduce product or increase reactant. Okay, let's look at another question. To help us understand this. We'll remove this one on the screen. Now, imagine for instance I have a reaction. So let's look at the screen. SO2 gas plus O2 gas reacting reversibly to give SO3 gas 2. Now, if you have this thing now, and I say, which one of these will favor the production of SO3? What do you think will be the answer? Give me all the things that will give more of SO3. Let's say option A. I said, which of these conditions will favor the production of SO3? SO3 is the product, right?
Yeah.
So we're looking at what will favor the production of SO3 or increase the product. Let's look at that. So I said option A. Let me give you options. Increase SO2. Option B. Decrease SO2. Option C. Decrease O2. So what do we think is the answer amongst these three? Are we going to increase SO2, decrease SO2, or decrease O2? So what do we think?
Increase SO2.
Increase SO2. Good. Because we said that anytime you hear favor forward, there are two things. Check your notes. What do we say are the two things when you hear favor forward? The two things you need to take note of when you hear favor forward is one, increase the reactant or reduce the product. Amongst the option, there is no reduction of product. This is the reactant. SO2 is the reactant. O2 is also the reactant. So which means that the only one we have now is the increase in the product. What did I just say? Okay, sorry about that. Retaking this, I said that anytime you are considering what favors the forward, remember the question says what is going to favor the production of SO3. The two things you need to do is either you reduce SO3, which is the product, or you increase the reactant. And the only answer that coincides with that is A. Now, having said this, what if I had said in the question, or I give you a question where you have N2 plus H2 reacting to give NH3, 3. And I say, for instance, which one of these would favor production of N2? So, option A, increase N2. Option B, increase H2. Option C, decrease NH3. And option D, decrease H2. So what do we think? Decrease. But let's look at it again. Someone says it's decrease H2. Now please go back to your note. I said favors production of N2. N2 is backward. What are the two conditions to favor the backward? The two things you are going to do for you to favor backward. Number one is what? Reduce the reactant. So which means that N2 is, we need to reduce N2 or reduce H2, which means A and B. N2 is a reactant, B says increase reactant. So what we need to do to favor backward is number one, reduce the reactant. A and B do not reduce the reactant. Okay, we go to C. What's the other condition to favor the backward? Increase the product. Increase the product or reduce the reactant. Now, in this case, they said we should decrease the product. No, that's not it. To favor the backward, what you need to do is reduce the reactant or increase the product, which means this decrease in NH3, which is the product, doesn't coincide. Am I communicating? Now, for you to be able to understand this, we take it again. The conditions to favor the backward is reduce reactant or increase product. And if you notice, option D says reduce H2, which is the reactant. I hope this is clear. In the physical class. Okay, those in the physical class, how far? Okay, now, having said this, a little bit of confusion. Let's try out one more question on this. Imagine, for instance, we have let's see if we have something like H2 plus O2 reacting to give, here you have 2. Now if they say which one of these would Please, is H2O the product or the reactant? It's the product. So please, everybody, go to your note and check. What are the two conditions to favor the product? The first one, or number one condition, is increase reactant, is decrease product. These are the two things that will favor forward. In your question, are we supposed to be favoring forward or backward? Forward, because the product is in the forward reaction. So let's look at this. Option A says increase H2O. Option B says increase H2. Option C says decrease O2. And option D says decrease H2. So what's our answer? What do we think is the answer? B. Okay. There's a little bit of lagging here, so I would like to just take 2 minutes just to address the whole network issue. Okay, thank you very much. Just 2 minutes and that will be resolved. Okay. So sorry about that. We had to resolve the network issue, but I think at this point it's going to be all green. Now, for those of you that probably had some issues with getting what we described earlier, the simple advice I would like to give is this: the video is going to be available for you guys. You can easily access it whenever you are done with this class. You get the class is, as I said, it's designed in such a way that you can go and listen to it after the class to fully understand. And remember, you are still in that group. You can ask me questions with respect to whatever confusions you have. So please, it's no bother. And for now, I'm sure the internet has been resolved. The network issue will not be an issue. Now, let's continue the class. To end that, we would have to continue with what we are discussing. I just want to use one final question to conclude this whole concept of concentration. Just one question. But before that, I just want to mention this. Remember to favor forward or favor, okay, sorry, let's use the term. So to favor forward, for those of you that could not get this, please write it down. To favor forward or increase product. The two things to do. Number one, increase reactants. When they say increase reactants, they are trying to say add the reactants or increase the concentration of reactants. Or reduce products. These are the two things that you need to do such that the equation or the system will favor the forward reaction or increase product. So just put that down, that you should increase reactants or reduce products. Once you're able to follow this thing, obviously and most definitely, you are going to have the answer to the question. Now, the second thing I would like you to take note of is to favor backward or increase reactants. Whenever you hear the term favor backward, it simply means increasing the reactants. So to favor backward or increase reactants, what you're supposed to do is, number one, increase product. Then number two, reduce reactant. Now please, if you just take note of these two things, whenever you see a question, all I want you to do is look at these two things and answer the question. So please, finally, on this, imagine you have a reaction between, let's say you have H2SO4 plus NaOH. This is a neutralization reaction, and it's going to give us Na2SO4 plus H2O. Now, if I say which of these will favor the forward reaction, let's say which of these will favor the forward reaction. Now, if I'm asking what will favor the forward reaction, it means increasing product, right? Good. So, conditions to increase, I'm writing it out before I write my option. Conditions. What are the conditions? Number one, if I'm going to increase or favor the forward reaction, I need to do what? Increase reactant or decrease, right?
Yeah.
Product. Abi?
Yeah.
Okay, so amongst the options, you tell me your answer. Option A is increase Na2SO4. Option B is reduce H2SO4. Option C is reduce H2O. And option D is reduce NaOH. So, based on this, what's going to be our answer? Can you pass me water? I'm really shouting, sorry. Okay. Okay. Sorry. Sorry about that. But let's continue. Yes. So for those of you that answered C, sorry sir. Thank you very much. It's okay. I appreciate all our sympathies. Let's continue. What's the answer? Maureen said C. Chisom Favor said sorry. Chisom Favor, what's your answer? Chisom Favor, what is your answer? Okay, so the answer is C. Let me resolve something and get back to you guys.
I'll give you first.
Fine. So can you hear us? Can you hear me? So what I was trying to say is like when I want to increase the
Shut up.
the
You go see me
oh, like,
You go see me go. They talk rubbish. You go see me go.
I didn't ask who is here.
well, do you know this is like actually live? We didn't know.
It was a live, I was alive.
Okay.
I'm sure you muted the
Yes,
We
it
did
did.
Hope you guys know that this thing is not huge.
What? It wasn't.
No, it was there. Yeah. It was.
Okay, sorry guys about that. Had to take care of some things. So let's continue. The answer is obviously C. Why? How do we know? If we are going to get the product, which is in favoring the forward reaction, the two things to do to get the product of forward reaction is increase reactant or you decrease product. Option A says increase Na2SO4, which is a product. Wrong. What you do to product is you decrease product. For you to favor the forward reaction, you decrease product. Option B is reduce H2SO4. And what you do to reduce, once you are talking about reducing H2SO4, you are reducing reactants. No, that's wrong. Because what you do to favor forward is increase reactants. Option C is reduce H2O. H2O is the product, and yes, it coincides. Once you reduce the product, automatically you get a favoring of the forward reaction, and that's why that is correct. Okay. So, Chukwebuka Stanley, I hope your confusion has been clarified. The two things you need to do if you are favoring forward: increase reactants or you reduce product. Okay, that is that about concentration. We will go to the next concept, which is temperature. Now, I'm going to try to summarize some things about temperature. First of all is that the two reactions that you can have for temperature, the two reactions that you can have, temperature, the two possible reactions that can occur with respect to chemistry are endothermic and exothermic reactions. Once you see that the enthalpy of a reaction is positive, it means that it's endothermic. Once you see that the enthalpy of a reaction is negative, it means that it is exothermic. This is endo, while this is exo. So this is endothermic. Once the H is positive, endo. Once the H is negative, exo. Once the H is positive, endo. Once the H is negative, exo. Okay, now okay, so with that said, the implication of this statement is that if I have a reaction now, let's say I have this reaction, H2 plus O2 reacting to give H2O. This particular reaction now, the H is going to be negative. Now what does it mean? It means that this reaction is an exothermic reaction. How do I know that it's an exothermic reaction? Because the H is what? Negative. Now, the thing about exothermic reactions is this, or with respect to temperature. if you want to favor the forward reaction, just look at the sign. That's one thing I would like to tell you. Have this in mind, that when you want to favor the forward, look at the sign. If the sign is minus, it means you should reduce temperature to favor the forward. Which means in this case now, what is going to happen with respect to temperature to favor the forward reaction? Reduce temperature. The sign is telling you, this particular sign is telling you what to do to temperature. If for instance you had a reaction, Hi reacting to give H2 plus I2, and I have that the H in this case is positive. What does this mean? It simply means that you should follow the sign. If you want to follow the forward reaction, follow the sign. The sign here says positive plus increase temperature. I take it again, that once you consider a reaction, if you want to know what will favor the forward reaction, just look at the sign of the enthalpy change. Once you see that the H is negative, it means that the forward reaction is favored by minusing temperature, reducing temperature. But in this case, where the H is positive, the forward will be favored by increasing temperature. Are we getting what I'm saying? Now, if the forward is increase, the backward is decrease. Just have that in mind. Okay, so with that said, I think you guys should take note of this. Just right. In endothermic reactions, comma, the forward reaction is favored by an increase in temperature. An increase in temperature to give more products. So if they say which of these will favor the forward and is endothermic, the implication is increased temperature. But if it is backward that is being favored, you decrease temperature. Okay, then you write this. Secondly, number 2, on the other hand, the backward reaction of an endothermic reaction is favored by a decrease in temperature. The backward reaction is favored by a decrease in temperature. Yes, for endo. The backward reaction of an endothermic reaction is favored by a decrease in temperature. So once you decrease temperature, you're favoring backward. But if you increase temperature for endo, you're favoring forward. Okay, we go to the next one. Now the next one is exothermic reaction. So you write in an exothermic reaction, in an exothermic reaction the forward reaction is favored by a decrease in temperature. In an exothermic reaction, the forward reaction is favored by a decrease in temperature. While the backward is favored by an increase in temperature. While the backward is favored by an increase in temperature. While the backward is favored by an increase in temperature. Okay. So let's consider this question. Let's see this question to help us understand this. Okay, shalom. Okay, so if you look at the screen, currently we have a question. So let's attempt it. Everybody attempt the question. Tell me what you think. So what do we think? In the reaction 2HI reacting reversibly to give H2 plus I2. That the H, because there is no sign, they hope you know it's positive. Hope you know it's positive. Just have that in mind. They said the concentration of iodine in the mixture will be increased by what? Now, have that in mind that iodine is the product. What do we think? What do we think? Raising the temperature. B. Praise God. What do you think? Okay, so with that said, sorry for the brief delay. We had to work out some questions and get these things on the screen. My technician is terrible. You understand? He's a horrible human being, but let's leave it at that. So the screen, if you look at the screen, he scattered everything I said, he destroyed it. That's why it's taking us time to put up questions. But God will forgive him. Now, if we look up, the question says, in the reaction 2HI reacting reversibly to give hydrogen plus iodine, the H is equals 10 kilojoules. I told you guys before, and I'm saying it again, that once you don't see a sign, it is an indication that you are dealing with a positive enthalpy. I'm saying it now, and I'm saying it again. So, because in this question now, we are not seeing in this question, yes, we can't see any sign here. It means that it's positive. Now remember, I told you that if you want to favor the forward reaction, just look at the sign. The sign here is saying positive, which means anything that is going to favor the forward, follow the sign with respect to temperature. The temperature is positive, right? What does positive mean? Increase. Once you look at the sign here, positive means increased temperature, and once you increase temperature, it is going to favor the forward reaction. If there was minus here, it means that what you need to do to favor the forward is to decrease temperature. But here you have positive, and positive sign implies increasing temperature to favor what? Forward. Now note that the question said to give iodine. Iodine is in the forward reaction, so which means to favor iodine production, we need to increase temperature. Please, I hope this is clear. Okay, let's try this one quickly. I hope there will be no issue with respect to bringing out the question. Okay, quickly let's look up this.
You have a question.
Go ahead. Okay, so let's attempt this question. Look at it. Tell us what we think. If an equilibrium reaction will proceed favorably in the forward direction. Now, please, I did not mention this before, but let me say it now. When you see the term dH greater than 0, it is the same thing as dH equals positive. Those of you that did not write this thing, please write it down now. dH greater than 0 is equals dH equals positive. dH greater than 0 is the same thing as saying dH is equals positive. So which means in this question now, our dH is positive. That's what they are trying to say. So yes, what's the answer to the question? They said if an equilibrium reaction has delta H greater than 0, which means delta H is positive, right? Positive enthalpy. I told you that once you see positive, it means increased temperature for the forward to be favored. But if you see negative, it means decrease. Am I communicating with you? Good. So just have that in mind. Okay. So in this case now, what are we going to have? High temperature, which is A. Good. Maureen Onyedikachi, your answer is the answer you're giving me, is it for the first question or the second one? If it is for this one, where we're talking about a dH greater than 0, then the answer is A. Okay. Now, moving ahead, let's try this one. Finally on this, let's try this finally, and then we'll leave temperature and talk about pressure, and then give you a brief EXO. Where is EXO? EXO. So everybody, let's try this. Let's try this. Look at it and answer the question. What do we think? Okay. Yes, those in the live class, I mean physical class. Alpha, what do we have? He said, what will happen if more heat is applied to the following systems at equilibrium? Okay, let me rewrite this equation. Let me write this equation so it will be clearer to you guys. Writing it is x2 gas plus 3y2 gas. Okay. Let's write this thing, make it easier. Okay. So you have x2 gas plus 3y2 gas reacting reversibly to give 2xy3 still gas. However, the H is equals negative. Okay. Sorry, sir. So looking at this now, what do we think? Now, the H is negative, which means if you are going to be favoring the forward reaction, negative means minus. Negative means that you need to reduce the temperature for you to favor the forward reaction, which means the backward will be favored by an increase in temperature. If you have a dH equals negative, what it simply means is that the forward is favored by a reduction in temperature, which means production of xy3 is going to be favored by reducing the temperature. If you now want to increase x2 or y2, you now have to do the opposite of this sign, which is increase the temperature. Now let's look at the question. The question says, what will happen if more heat is applied to the following system at equilibrium? Please, I hope we know that when we say more heat is applied simply means that you are increasing the temperature. Hope we know that. Now, remember that we said once you increase the temperature, something is going to happen. What is going to happen in this case? If you increase the temperature, it will favor the backward reaction. Why? Because the forward is favored by decrease in temperature. So when you increase temperature, it's backward you're favoring. So look at it now, which means we're going to have more production of X2 or more production of Y2, or you will hear less decomposition. More production of Y2 and X2 means more decomposition of this guy. I take it again. This is an addition or combination reaction to give this. Then the backward is that this guy is breaking down to give X and Y. So when you consider this particular system, negative means forward or combination of X and Y is favored by reducing temperature. But the question says the temperature was increased, which means backward. What is happening backward? XY is broken down to give X and Y. So the composition of this guy is going to be increased. So let's look at that. Option A says not clear. Okay, please, I do not understand the question. Let's reiterate again. Sorry about the confusion, but just please try to listen. The problem might be that you might not understand the term addition or decomposition. Let's look at it again. Now, once the H is negative, if the H is negative, we said that if you are going to produce the forward or favor the forward and the H is negative, you need to follow the sign. Negative means to reduce temperature. But the question did not talk about reducing temperature. The question talked about increasing temperature. The question talked about increasing temperature. And if we are talking about increasing temperature, for a negative reaction, it means that we are going to be favoring the backward. So listen, once we say increase temperature, which is what the question says, now we need to favor the backward. I guess what I'm saying. Now, favoring the backward means that I'm increasing X or increasing Y. And then for you to talk about increasing X or increasing Y, they did not give those things directly in the question as increase X and increase Y. That's the thing. So what other way can they say that X and Y is increased? When they say X and Y is increased, how is X and Y increased? It means that this guy was decomposed. As you are decomposing this guy, X and Y is increased. And if you look at the options, the yield of X3, Y3 will be decomposed. Okay, B, more XY3 will be, I think this is decreased, not decomposed. Yes, the question is relatively very weird. This is not supposed to be decomposed. This is supposed to be decreased. So take note of that. Option A, this is supposed to be decreased. Then B, more of XY3 will be decomposed. I think this should be the answer. And why I'm saying more of XY3 will be decomposed is if more of this is decomposed, more of this will be produced. An increase in exothermic means that backward will be increased. It's looking a little bit confusing, but just look through it again and probably go back to what we said initially. I said if you follow the sign, it's favoring forward. But when you don't follow the sign, it's favoring backward. This question now did not follow the sign because they said increase when the sign is saying decrease. And because they did not follow the sign, we are going to be giving these backward guys X and Y. Now the options did not directly say increase X, neither did it say increase Y. So what else can they say? Decompose this guy. Because when you are decomposing this guy, you are getting X and Y. So have that in mind. Now the answer to this question is going to be more of XY3 will be decomposed. That's the answer. B. I told you that this particular decompose here is not decomposed. I think they meant decrease. So please correct it. This should be decreased. For those that are writing down the questions, this should mean decrease. So with that said, B is going to be our answer. Okay, now just to be sure that we got this, I just want to give you one final question before we move into the other thing we have. Just to be sure that we got this, please attempt this question. Okay, the question is up on the screen, so just attempt it. Oh my god. Another confusing question. Okay, now let me just say something. when they say equilibrium constant increases, if the equilibrium constant increases, it means that it favors the forward process. So please write that down. An increase in equilibrium constant implies favoring of forward process. An increase in equilibrium constant implies favoring of forward process, while a decrease in equilibrium constant implies favoring of backward process. So the other way they can say favors forward process is increase in equilibrium constant. The other way they can say favors backward process is decrease in equilibrium constant. So please, with that understanding, you know this is a technical study, so you need to be thinking. If you can't think, you would hardly understand this. So please think. I said in this question they said what happens to the equilibrium constant. Just forget about what happens to equilibrium and think about, is it favoring forward or is it favoring backward? If you can answer whether it's favoring forward or backward, okay, that's those online, just answer, is it favoring forward or is it favoring backward? That's what I want to get from you, first of all. So if you get the fact that it favors forward favoring means increase in equilibrium constant. When it's favoring backward, it means decrease in equilibrium constant. So what do we think for the question? Yes, those in the class, what do we think? Okay, so as we all said, those that responded, Edwin, Grace, and Maureen Onyedikachi, the two of you are correct. So listen, we said initially that once you are dealing with a question, there are so many things to take note. When it's equilibrium constant, the questions can be very confusing. Now, what I mentioned initially is that increase in equilibrium constant means that the forward reaction is favored. So if you look at this reaction now, if we consider this reaction, the forward reaction, this is minus, negative, which means the forward reaction is favored by a decrease in temperature. And in this question now, they said that the temperature is increased. If the temperature is increased, it will not favor forward because forward is minus. So anytime you increase temperature for a negative reaction, what it is going to increase is favoring backward. If you check what we wrote initially, when you favor backward, it means that equilibrium constant decreases. So our answer is simply going to be C, and you have that. Now, let's leave this and get into pressure. Now, the thing to note about pressure is this. Just write this down if you can. Write this down if you can. That's the most important thing to note about pressure. Let me take this out. So write this down, that an increase in pressure favors the side with less number of moles, while a decrease in pressure favors the side with more number of moles. So let's put this down, that if you increase pressure, the side you are going to be favoring is the side with less number of moles. But when you decrease pressure, the side that will be favored is the side with more number of moles. I mentioned this earlier, and I just want you to take note of this. If we are answering questions, all I need you to do is look at that particular concept, and then once you look at it, ask yourself what happens here to favor the forward, what happens here to favor the backward. If you are going to favor a forward reaction, just note that's what you need to do. If you are going to favor the side in the reaction with less number of moles, what you need to do is to increase pressure. If you are going to favor the side with more number of moles, what you need to do is to decrease pressure. So always have that in mind, that whichever side is favored is dependent on the number of moles. Anytime you increase pressure, you are favoring the side with less number of moles. But when you decrease pressure, you're favoring the side with more number of moles. Okay, having said that, I would like you to write this down too. A very important note. Change in pressure does not affect a system. Change in pressure does not affect a system. Change in pressure does not affect a system. Change in pressure does not affect a system with no gases. Change in pressure does not affect the system with no gases. Okay, so I presume we've written that change in pressure does not affect the system with no gases. What do I mean by that? If you have this reaction, for instance, now let's look at this screen. If the screen says, or if a question says that you have a reaction where let's say no, not this. Let's use a neutralization reaction. H2SO4 aqueous plus NaOH aqueous, and it is reacting with to give Na2SO4 aqueous plus H2O liquid. If you notice, there is no single gas here, and automatically once there is no gas, the implication is that pressure cannot affect the system. Why won't pressure affect the system? There is no gas. Here you have aqueous, here you have aqueous, here you have aqueous, here you have aqueous. Once you notice that there is no gas in that system, the implication is that pressure does not affect this system. That's that. Now, the next thing I would like you to write is, if the number of moles of gases on the reactant and product side are the same. Take it again. If the number of moles of gases on the reactant and product side are the same, change in pressure does not affect the system. If the number of moles of gases on the reactant and product side are the same, change in pressure does not affect the system. If the number of moles of gases on the reactant and product side are the same, change in pressure does not affect the system. So what do I mean by that? Imagine you had a reaction where you have H2 gas plus iodine gas. Iodine normally is solid at room temperature, but you know it's sublimed to form the gaseous state. So when hydrogen gas and iodine gas reacts to give 2 hydrogen iodide gas, if you look at this screen now, this should be an exothermic reaction. So let's say this is exothermic. Now look up. How many moles of the gases? Everything here is a gas, right? So can pressure affect it? Can pressure affect it?
Yeah.
It can't. See the reason. Even though all of them are gases, you will notice that 1 mole of hydrogen is on this side plus 1 mole of iodine, which means altogether on the reactant side you have 2 moles. On the product side you have 2 moles. And once the moles of gases on the reactant is equal to the moles of gases on the product side, automatically change in pressure does not affect the system. So just have that in mind, that the systems that can be affected by change in pressure are only systems that have gases, number one, and then you have to make sure that gases on the reactant and product sides are not equal. So have that in mind. Okay, let's try this question to help us understand it. I'm giving these questions because it's not about teaching the concept, it's about knowing how to answer the questions associated with them. Okay, so the question on the screen: what will be the effect of increase in pressure on the following systems at equilibrium? I think I'll need to rewrite. Let me rewrite the equation so it will be like clearer for everybody. The equation is 2NH3. Oh, that's bad. Sorry, look at the actual equation. Reacting reversibly to give N2 gas plus H2 gas. Oh, I think I should rewrite this. Just okay. So I said the equation is 2NH3 reacting reversibly to give N2 gas plus 3H2 gas. Emphasis, all of them are gases. So please, let's look at it. What do we think is going to be the answer? So those online, just comment. What do you think is going to be the answer? Okay, Chukwuebuka Stanley says D. The reaction will go to completion. Chukwuebuka Stanley, did you even listen to what we said about pressure? Okay. Okay, D. I'm not sure yet. Let's keep answering. Those online, what's the answer? Those in the physical class. Someone says C. Now, I think I will need to do this analysis myself, then you guys answer a consequence question. Now, let's look at this. Remember what we said about pressure. That when you are dealing with pressure, it's not favors forward or favors backward. It's favors side with more or favors side with less. So listen, if you look at this reaction now, you will notice that this side has 2 moles, while this side has 1 mole plus 3, which is 4 moles. The question says, what will be the effect of an increase in pressure? We said that when you increase pressure, it favors the side with less number of moles. When you increase pressure, it favors the side with less number of moles. It's quite simple. This side has more moles, this side has less moles. So when you increase pressure, it favors the backward reaction, which means it's going to give more of ammonia. And that should be option C. Is that it? So I hope this is clear. When you increase pressure, it favors the side with less number of moles. Less number of moles is on ammonia side, and that's production of ammonia. Praise God. Clear? Good. Yes, Maureen, you are correct. Anya Muchi Debere. Edwin Grace. Okay, you've seen. Yeah, Edwin Grace is correct. Wogu, Angela, B. Look at it again. Remember we said that if you increase the pressure, forget about forward and backward, just take the point I said, that when you increase pressure, system favors the side with less number of moles, but if you decrease pressure, it favors the side with more. In this question now, if you look at the question says what will be the effect because of an increase in pressure. Increasing pressure in this case would favor the side with less, which means the side with less is ammonia. That's backward reaction, which means that ammonia would be increased. Please, I hope this is clear. Okay, for those online, yes. Edwin, you are correct. Anyanwuchi Debere, you are correct. Chukwuebuka Stanley, yeah, cool. Bernard, I don't understand, please. Okay, now for Bernard's sake, I'm going to give one more question to explain this. Let's look at this question quickly. Okay, no, this is not the right question. Okay, so let's attempt this question. Let's attempt this question. Let's attempt this question. What do we think? There is no effect. Are you sure?
Yeah, solids and liquids.
Solids and liquids, there's no gas. Are you sure there's no gas? You can't see the question. Please, if you can't see it, zoom. The question is clear now. Those online, what do we think? Okay, I think there's a little confusion to this statement. You know, when they say favors forward reaction, it means shifts towards the right. Backward is shifts towards the left. So everybody, please put this down if you're following this class. Put this down if you're following this class. Now, when they say favors forward means shift towards the right. Favors forward means shift towards the right, while shifting towards the left is favoring backward. Shifting towards the left is favoring backward. Forward is towards the right, backward is towards the left. Okay, so now let's look at the question properly. Now, if you look at this question now, please, I think it is quite easy to understand. You can't see what I'm seeing. Now if we look at, let's consider this is a solid, this is a gas, this is a solid, and this is a liquid, not a gas. Okay, so let's write. I'll write that down. Let me write it down for everybody to see. CuO solid plus H2 gas reacting reversibly to give Cu solid plus H2O liquid. Now, the total number of moles of gases here is how many? 1. So here you have 1 mole of gas. But on the reactant side, how many moles of gases do you have? None. 0. There is no gas on the product side. And because there is no gas on the product side, the mole of gases on this side is greater than the one on this side. Now, please remember I said, when you increase pressure, system favors the side where there is less number of moles. But when you decrease pressure, it favors the side where there is more number of moles. So please, Bernard, please listen. I take it again. I think you should go back and look at it again. I said it that whenever you are increasing pressure, the system favors the side where there is less. But when you decrease, system favors the side where there is more. So if we are looking at the question is saying that what is the effect of increasing pressure? If you increase pressure, it will favor the side with less. Please, which of these two sides are with less? You find out that it's towards the right, which is the product side. So when you increase pressure, system will favor the side where there is less, and the side where there is less gases is in this equation though is towards the product, which is the sorry, did I say the left or the right? Sorry, this is the right side. So forward reaction, which is towards the right. So just have that in mind. So moving towards the right is option B. So our correct answer is B. So Principets, Maureen, Chuku Principal, oh, same person. Principal, did you? Oh, okay, yeah. Chukwuebuka Stanley, correct. I hope this is clear to everybody. Now, this is actually the end of this particular study on chemical equilibrium. What I just want to tell you is this: the video is there for you guys, so go and look through it again. If you have questions, the group chat is open for you to ask those questions. Now, for want of time, I would just give you straightforward formulas. You know, we said we are going to do something on pH. I just want to give you straightforward formulas on resolving issues with respect to pH, and we'll now get into we might call it off at that. Yes, some of you might be asking, what about the thermodynamics? I will have to reschedule to do the thermodynamics class. If it's possible, you can give your opinion. Should we continue or should we reschedule to do the thermodynamics class? We can do still. You don't have to pay extra for that. We can actually have the thermodynamics class if you guys want to later on today. But I'm looking at giving you guys a break for now. But I must finish pH and pH before I leave you guys. So, however, for the thermodynamics class, what do you think we should do? Should we reschedule or continue? Preferably, I would say we reschedule to later in the night. Then everybody is home. The service is even better. You get. But I must talk about pH. So let's talk about pH. So send out your opinions. I will take note of them, and that will be that basically. Okay, now pH and pOH simply describes measure of acidity and alkalinity. So please, everybody put that down. pH and pOH is a measure of acidity and alkalinity. pH and pOH is a measure of acidity and alkalinity. But before we get to discuss it in details, there are things I should repeat. Okay, pH and pOH is a measure of acidity and alkalinity. pH and pOH is a measure of acidity and alkalinity. Okay, now having said that, before we come to this pH and pOH, that's mathematically solving questions, there are important things you must note. The first important thing that you must note is ionic product constant of water is equals 10 raised to power minus 14. So please put that down. Ionic product constant of water is equals 10 raised to power minus 14. So some of you might be asking, what is ionic product constant of water? How did we get it? It's quite simple. An autoionization reaction of water is when two molecules of water react to form ions in water. Autoionization is simply a process where neutral molecules react, but neutral molecules of the same substance react to produce ions. So when water, H2O liquid, reacts with water, H2O liquid, and after that reaction, ions are produced. The ions produced here are H3O plus and OH minus. This is aqueous. This type of reaction is what we refer to as autoionization. Now, with this said, must the symbols be represented with gas? The symbols of the state of matter must be indicated, because if it's not indicated, when you are solving questions with respect to equilibrium constant, you would have a lot of issues. So please, yes, the state of matter must be indicated. Now, if you look here, if we decide to write the equilibrium, yes, talking about the equilibrium constant, everybody write the equilibrium constant for the forward reaction of this process. If you write it, what is going to be your answer? The equilibrium constant for this reaction is going to be concentration of H3O plus raised power 1 times concentration of OH minus raised power 1. Now, divided by, this is liquid now, Once it's liquid, we don't need to put it. It's going to be 1. This is also liquid. This is also going to be 1. What does it mean? The equilibrium constant of this reaction would be concentration of hydrogen ion multiplied by concentration of hydroxyl ion. Now, my point about this, or why I'm emphasizing this, is this. The equilibrium constant for this particular autoionization reaction is what we call ionic product constant of water. So what does that mean? K of W is equals conc of H3O plus times conc of OH minus. Now, please, I must say this. If you have a little issue with understanding this, just go back to the video later on. The most important thing you need out of all these things I just said is this guy. So just have in mind that the ionic product constant of water, brackets, K, this is KW, is going to be equals concentration of the hydrogen ion multiplied by, this is dot product, multiplied by the concentration of hydroxyl ion. Okay, now, if we have this, you would find out that I can also say, since KW is ionic product constant and it's 10 raised to power minus 14, it simply means that 10 raised to power minus 14 is equals conc of H3O plus times conc of OH minus. Now, please, let me just say this. You can use hydrogen ion in place of H3O plus. So that means that 10 raised to power minus 14 is equals conc of hydrogen ion multiplied by conc of hydroxyl ion. These two things are exactly the same thing. These two things are exactly the same thing. So whether you have this or you have that, they are exactly the same thing. I'm sorry, can you guys just give me 2 minutes to resolve something? The network seems to be having an issue. Let me quickly resolve that and get back to us. Now, so for want of time and to prevent the whole diminishing return, we are going to reschedule the class for later in the night. We'll continue the class later. So thank you very much for joining the class. Remember, I'll send the link out to the group. This class continues till we finish the studies we talked about. So go back to the group and suggest your likely time you would want us to have the class. Thank you very much. And that will be that for today. Before I leave, those of you that have not subscribed, please go and subscribe. Thank you very much.